Good evening, everyone. Today, I'll be presenting a topic on computer networks called sliding window protocol, along with go back and selective repeat protocols. In computer networks, reliable communication is extremely important. Whenever data is transmitted from a sender to a receiver, it must arrive correctly in the right order and without being lost or corrupted. To ensure reliable communication, data link layer uses mechanisms such as flow control and error control. One of the most efficient techniques used for this purpose is the sliding window protocol, which forms the basis of the go back and selective repeat protocols. In this presentation, we'll understand how these protocols work and how they improve the efficiency of data transmission. In next slide, we'll be learning about what is communication in computer networks. In computer networks, communication takes place between two entities, a sender and a receiver. Data is transmitted in the form of frames or packets through the network. However, several issues can occur during data transmission. First, the sender may transmit data faster than the receiver can process it. Second, frames may get lost or corrupted during transmission due to noise or network errors. And third, if too much data is sent at once, network congestion may occur. To deal with these challenges, networking protocols implement mechanisms such as flow control and error control, which help maintain reliable communication. What is flow control? Flow control is a mechanism used to regulate the speed of data transmission between the sender and the receiver. The main purpose of flow control is to make sure that the sender does not overwhelm the receiver with too much data. If the flow control is not used, several problems may occur. For example, the receiver's buffer memory may overflow if frames arrive too quickly. As a result, frames may be dropped and important data may be lost. Therefore, flow control ensures that the sender transmits data at the rate that the receiver can safely process. This leads to smoother and more reliable communication between devices. Now, stop and wait protocol. One of the simplest methods used for flow control is the stop and wait protocol. In this method, the sender transmits only one frame at a time. After sending the frame, the sender waits for an acknowledgement, commonly called an ACK, from the receiver. Once the sender receives the acknowledgement, it sends the next frame. Let us get this with an example. The sender sends frame 1 and waits for an acknowledgement 1. After receiving the acknowledgement, the sender sends frame 2. This method ensures reliability because each frame is acknowledged before sending the next one. However, it is not very efficient. Now let us see some of the limitations of stop and wait. The stop and wait protocol suffers from several limitations. The biggest issue is low efficiency. Since the sender must wait for an acknowledgement after every frame, a lot of time is wasted waiting rather than transmitting data. This problem becomes more serious in networks where the round trip delay is large. For example, if the transmission time of a frame is very small but the acknowledgement takes a long time to return, the sender remains idle most of the time. This leads to poor bandwidth utilization. To solve this inefficiency, more advanced techniques such as the sliding window protocol were developed. Yeah, now let us see an introduction to sliding window protocol. It is designed to improve the efficiency of data transmission. Instead of sending one frame at a time, the sender can send multiple frames before receiving acknowledgements. This is achieved by maintaining a group of frames known as window. Each frame is assigned a sequence number so that the receiver can identify the correct order of frames. By allowing multiple frames to be transmitted simultaneously, the sliding window protocols makes much better use of network bandwidth. This significantly improves the speed and the efficiency of communication. Through this technique, multiple frames are allowed to be transmitted simultaneously. Yeah, let us see how the sliding window protocol works. In this, in the sliding window mechanism, both the sender and the receiver maintains windows. The sender window contains frames that have been sent but have not yet been acknowledged. The receiver window represents the frame that the receiver is ready to accept. Suppose if the window size is 4, the sender can transmit frames 1, 2, 3, and 4 without waiting for acknowledgements. When the receiver sends an acknowledgement for frame 1, the window shifts forward and the sender can transmit frame 5. This movement of window is called sliding. This is why the protocol is known as the sliding window protocol. So we can summarize it and say that once the receiver acknowledges frame 1, the window moves forward and the sender transmits another frame. So this movement of window is known as sliding. Now let us see some of the advantages of sliding window. The sliding window technique provides several important advantages. First, it allows multiple frames to be transmitted simultaneously, which increases the speed of communication. Second, it reduces idle waiting time between transmissions. Third, it improves bandwidth utilization, meaning the network resources are used more efficiently. It allows multiple frames to be transmitted simultaneously, increases overall network throughput. So because of these benefits, sliding window mechanisms are in many communication protocols. So these mechanisms are also widely used in many modern communication protocols. Now let us learn about go back N protocol. One important protocol based on the sliding window concept is the go back N protocol. This protocol is used for error control. In go back N, the sender can transmit multiple frames without waiting for acknowledgements. However, the receiver only accepts frame in the correct order. In clear words, we can say if a frame is lost during transmission, the receiver discards all frames that arrive after the missing frame. This ensures the frames are processed in the correct sequence, but it may require retransmission of several frames. So let us see an example of go back. Suppose the sender transmits frame 1, 2, 3, 4, and 5. And let us say if frame 3 is lost, the receiver successfully receives frame 1 and 2. However, when frame 4 and 5 arrive, the receiver discards them because frame 3 is missing. Since the receiver only acknowledged the last correctly received frame, the sender eventually realizes that frame 3 was not acknowledged. The sender then retransmits frame 3 and all subsequent frames, which means 3, 4, 5 frames are sent again. This process of going back to the lost frame and retransmitting the following frames gives the protocol its name go back N. I hope this go back N protocol is clear now. Next, uh, let us talk about selective repeat protocol. Another important sliding window protocol is the selective repeat protocol. The selective repeat is designed to improve efficiency compared to go back N. So in this, instead of retransmitting multiple frames, selective repeat retransmits only the frames that are lost or corrupted. This makes the protocol much more efficient, especially in networks where errors occur frequently. So first let us see what is the need for selective repeat. Although go back and improves efficiency compared to stop and wait, but it still wastes bandwidth. If one frame is lost, several correctly received frames must be retransmitted. This leads to unnecessary retransmissions and inefficient use of network resources. To overcome this limitation, the selective repeat protocol was introduced. Selective repeat minimizes the retransmissions by sending only the missing frames again. So let us see the definition of selective repeat. So selective repeat is an error control protocol where the receiver can accept out of order frames. Instead of discarding frames that arrive after a missing frame, the receiver temporarily stores them in a buffer. Only the missing frame is requested for retransmission. Once the missing frame arrives, the buffered frames are delivered to a higher layer in the correct order. This approaches this approach improves the efficiency of data transmission. So let us see the window mechanism. In selective repeat protocol, both the sender and the receiver maintains window. The sender window size is n, and the receiver window size is also n. This means the receiver can accept multiple frames even if they arrive out of order. The receiver temporarily stores these frames in memory until the missing frame arrives. Once all frames are available, they are delivered in the correct sequence. Let us see an example of selective repeat. Consider the same example where the sender transmits frame 1 to 5, and suppose if frame 3 is lost, the receiver receives frames 1 and 2 normally, where frames 4 and 5 arrive instead of discarding them. The receiver stores them in a buffer. The receiver then requests retransmissions of frame 3. This allows the protocol to avoid unnecessary retransmissions. So now let us see what is retransmission in selective repeat. When the receiver detects that frame 3 is missing, it sends a request to the sender to retransmit only that specific frame. The sender retransmits frame 3 only. Once frame 3 arrives, the receiver now has frames 1, 2, 3, 4, and 5. The buffered frames are then delivered in the correct order. Now, this whole process makes the selective repeat much more efficient than go back and protocol. So now let us see about advantages of selective repeat. Selective repeat provides several advantages. It provides bandwidth efficiency because only lost frames are retransmitted. It reduces network congestion and unnecessary data transmissions. It also performs well in networks where transmissions error occur frequently. Because of these benefits, selective repeat is considered as more efficient than go backend. But there are some disadvantages of selective repeat also. The protocol is more complex to implement compared to go backend. Here, the receiver must maintain buffers to store out of order frames. This requires additional memory and processing power. Therefore, although it is more efficient, it is more complicated. If we do a comparison between these two protocols, between go backend and the selective repeat, we can say in go backend, the receiver window size is only 1, while in selective repeat it is n. Go back and discards out of order frames, whereas selective repeat stores them. Go back and retransmits multiple frames when an error occurs, while selective repeat retransmits only the lost frames. And as a result, selective repeat is more efficient but also more complex. So, to conclude, the sliding window protocol is a fundamental mechanism used in computer networks to improve the efficiency of data transmission. Two major protocols based on this technique are go backend and selective repeat. Go backend is simpler and easier to implement, but it may waste bandwidth due to retransmission of multiple frames. Selective repeat is more efficient, but it retransmits only the lost frames, although it requires more complex implementations. At the end, both protocols play a crucial role in ensuring reliable and efficient communication in modern computer networks. So yeah, this was all for it. Thank you.